conventional detergent are widely used every day, but there was causes water pollution and corrosion of metals. The surfactant content found in the petroleum-based detergent is difficult to decompose and has a negative impact on the environment. Therefore, an environmentally friendly alternative is needed, such as ecoenzyme, which is derived from feed and vegetable waste. Ecoenzyme has antibacterial, natural cleaning, and biodegradable properties. In addition, Duku fruit peels contain tannin compounds that can function as corrosion inhibitor and protect metals from damage.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, allow us to introduce. We are from Spelling team and my name is Keysa Aurelia
And my name Novia Najma.
And we are from two State Islamic Senior High School KUDUS. Do you know the impact of detergent waste on environmental pollution? Based on the video that was shown earlier, we can see how dangerous this waste is to our environment. With Indonesia's population reaching around 275 million people with 50 million households, the amount of detergent used each year reaches 900 tons, which eventually turns into liquid waste. Thus, the total amount of detergent used each year is 18 tons.
Can you imagine how terrible it is? For that, we created an environmentally friendly biodetergent innovation made from natural ingredients with the title
EcoLab,
Ecoenzyme and Lenzones Anti-Rust Biodetergent.
Utilization of ecoenzyme and Duku peel extract in making anti-corrosion biodetergent.
The objectives of this research are: first, knowing the characteristic of EcoLab biodetergent produced from ecoenzyme and Duku skin waste. Second, knowing the effectiveness of EcoLab in preventing corrosion of metals. Third, knowing the effectiveness of EcoLab in inhibiting Staphylococcus aureus bacteria.
The first is making ecoenzyme. Making ecoenzyme is done by mixing brown sugar, vegetable fruit waste, and water in the ratio of 1:3:10. The second is preparation of Duku peel extract. The Duku sample was soaked in 96% ethanol in a ratio of 1:10 and incubated at room temperature for 24 hours while stirring. After the maceration process, then filtered. The third is phytochemical test of Duku peel. Phytochemical test is the process of identifying chemical compounds contained in Simplicia. Phytochemical tests on Duku skin include alkaloid test, flavonoid test, saponin test, and tannin test. Number 4, manufacture of liquid biodetergent. The manufacture of liquid biodetergent is carried out by mixing ingredients and adding ecoenzyme and Duku skin extract with extract variation of 0%, 0.5%, 1%, 2%, and 5%.
5. Detergent characteristic test. Detergent characteristic test includes organoleptic test, pH test, foam stability test, and cleaning power test on detergent. Number 6. Anti-corrosion testing on detergents. The metal is immersed in a liquid that has been given an ACL and also detergent that have been given variation of Duku skin extract for 2 times 24 hours, then washed and ovened before being weighed by the weight loss method. The result we get in this study are: 1. In the liquid detergent formulation was carried out with the addition of 4 variation of Duku skin extract, namely 0.5%, 1%, 2%, and 5%, making this biodetergent using MES and also ecoenzyme, which has the ability to effectively remove stains and produce detergent waste that is environmentally friendly and easily decomposed. Phytochemical content of Duku skin aims to provide an understanding of the group of compounds contained in the plant under study. The table shows that Duku skin extract contains alkaloid, flavonoid, saponin, and tannin compounds. These compounds are used as antibacterial compounds.
The detergent characteristics include organoleptic test, pH test, foam stability test, and cleaning power test. Based on the table of organoleptic test result above, it can be seen that the higher the concentration of Duku skin extract added, the more intense the color produced, but doesn't change the texture and the skin of each formulation. In the pH test that has been carried out, all formulation shows a pH value of 3, which doesn't meet SNI standards. This is because ecoenzyme fermentation carried out over a long period of time produces an acidic solution so that the pH is getting smaller. The data in Table 6 shows that the treatments F0 to F4 produce the same foam stability value. The stability value of the detergent test results is also better than the foam stability value of commercial detergent, which is 82.2%. The results showed differences in viscosity value of all formulation treatments. The viscosity value of the research liquid detergent is higher than that of commercial liquid soap. This is due to mass, which act as a thickener when left overnight in a water solvent. Based on SNI quality requirements, the specific gravity of liquid detergent products range from 1.0 to 1.3 gram per milliliters. In the data above, the specific gravity value of sample F0 to F4 doesn't include SNI standards. The study showed that there was no significant effects on the specific gravity value of each formula. The sedimentation test results showed that the 5 formulations experienced a decrease in sedimentation volume values, but F0, F2, and F4 were formulas that showed the slowest and least decrease in sedimentation volume. Anti-corrosion test was conducted by weight loss method. Based on the test that has been conducted, the negative control or NaCl showed the highest corrosion rate, which was 0.014. E3 and E4 showed the lowest corrosion rate, which was 0.002. This indicates that formulation with 2% and 5% extract concentrations have optimal effectiveness in inhibiting corrosion.
Conclusion are: first, the most optimum Ecolab biodetergent is F4, or 5% Duku skin extract with characteristic in the form of a very thick brown preparation with lemon-lime skin.
It's all the explanation of the research we have done. Don't forget to support us in ISPO 2025. Thank you very much and wassalamualaikum warahmatullahi wabarakatuh.